Ladies and gentlemen, please welcome Fielder Hiss.
Good morning, and welcome to our second day of SOLIDWORKS World here in San Antonio, Texas. Everyone have a good time yesterday? Good. What did everyone think of Gene Kranz and Jim Lovell? I thought that was awesome. When you think of working in an organization whose motto is failure is not an option, or success is the only option, that's an amazing way to look at things, an amazing way to think about changing the world. You know, their whole way that they work and think is all about trying to expect the unexpected. And they took that team of a very, very young team with very different skills and got them to work together because failure was not an option. That was hugely, hugely interesting. If I'm ever stuck anywhere with no power, no air, and a chance of being cooked by the sun, I want that team with me because it's an amazing, amazing story. And it's really a tribute to all of you as engineers. Only an engineer can figure out a way to take a square tube and put it in a round hole. That's the vision and the knowledge that everyone in this room really has, making the impossible possible. It was really interesting, and it really inspires us how each and every one of you every day works to change the world. Are my CSWPs in the room? A lot of you got out of bed this morning. I was a little worried after the event last night. I'll tell you, for those who didn't make it, alcohol and dart guns are not the best combination. That's all I'm going to say. But it looked like a great time. I met some great users, had some great conversations with some people, both new friends and old friends. And for everyone else, did they have a good time at the reception in the partner pavilion last night? Good. There's so much technology on display, so many cool products, so many great partners. And the reality is we couldn't do SOLIDWORKS World without our partners. Once again this year, Hewlett-Packard is one of our platinum sponsors, as they've been for many, many years. And to thank them, I'd like to welcome up Tom Solomon from Hewlett-Packard. Tom, come on up. Hey, Fielder, Tom. Here you go.
Well, thank you. Thank you very much. Yeah, every year I get to say about 30 seconds worth of information, so I always wonder what to say. But, you know, we really do enjoy and are honored to sponsor SOLIDWORKS World because we do it because of our partnership with SOLIDWORKS. And we also do it for you because we want to help you have the opportunity to learn and learn more. So we enjoy that sponsorship. And the other thing I wanted to tell you is, 2011 is here, right? And just like you, I think, I have this feeling it's going to be a great year. And sort of my mindset is it's about time, right? And this is a time where we can be really competitive. You know, with the skills that you have and the innovation you have, it's a chance to be hugely competitive. And so, think about this year a little bit and what you need to do and how you need to improve your productivity, shorten your design cycles, save time. And that's where HP can help you when you're using your SOLIDWORKS with our mobile workstations, our desktop workstations, and our printers. And you've already seen one really great example. Jeremy Lucchini, I think you know him, right? Everybody know Jeremy. And the chair that he designed and that work environment was done on an HP Z800. And in a little while today, you're going to see this awesome car design from a company called Local Motors, right? And that was also done on a Z800. So you're going to see our customers designing, and we like to think of it as thinking differently with HP, with SOLIDWORKS running on an HP. So have a great SOLIDWORKS World, and thank you.
Tom, thanks so much, everyone. A big round of applause for Hewlett-Packard. Tom, I think you're right. I think 2011 is going to be a great year. There's so much passion, so much energy in this room. And this is a large, large meeting of SOLIDWORKS users, partners, the community, and there's so much passion. But one of the things that's so important to our community is local user groups. And local user groups are really where you get together, learn from one another, share information, share knowledge. And we actually have an opportunity to often attend those and learn from you. And they're really such a valuable part of the vital community that we have. To talk a little bit about our local user groups, please welcome Richard Doyle, our user community manager. Richard, come on up. Richard.
So the SOLIDWORKS User Group Network enjoyed another successful year, and we rolled into 2011 with 195 user groups in 27 countries. And the credit for that success goes to the user group leaders that run those local chapters. And they're all sitting here with us today. Let's give them a big round of applause. Come on. Local user groups provide training, give you an opportunity to share information, and a chance to meet face-to-face with people that share common interests. If you're not currently a member of a SOLIDWORKS user group, you're missing out on a pretty unique opportunity. Each year, the SOLIDWORKS User Group Network Committee recognizes outstanding service to the SOLIDWORKS community. The User Group Leader of the Year Award and the User Group of the Year Award represent the pinnacle of that achievement. This year's winner of the User Group of the Year Award is one of the oldest and most respected user groups in the world. Formed in 1998, they've been serving their users for 13 years now. The impact of this group resonates throughout the community and probably set the stage for the founding of the SOLIDWORKS User Group Network. Ladies and gentlemen, please congratulate the Chicago SOLIDWORKS User Group, Denny Ball, Group Leader. Congratulations. Pictures. Congratulations, Denny. What can you say about a man that not only serves his own members, but also takes time to assist other user groups, providing ideas, technical presentations, and good positive reinforcement? A man whose passion extends beyond industry and into the educational system. Most recently elected by his peers as the new Eastern Region representative for the SOLIDWORKS User Group Network, please congratulate the User Group Leader of the Year, Ed Gibo. In March of last year, we lost a dear friend, a mentor, and a champion for SOLIDWORKS user groups everywhere. Michelle Pillars lost her fight with cancer, but she left a legacy that stands as a good example to past and present and future SOLIDWORKS users everywhere. Here to say a few words about Michelle is the longest-serving SWWN representative, Phil Sluter.
Michelle Pillars was a licensed professional engineer. She was a product designer, and she was principal at Evolution Design Engineering. She was an avid SOLIDWORKS user and proponent of SOLIDWORKS. Many of you may remember in SOLIDWORKS World 2004 in Boston when her and Sam Ramada got up on the big stage and showed off her product, the Photo 3D camera attachment. Many of you may still have the glasses that they handed out at that event. Michelle was a traveler, an artist, and a rockin' musician. She was an author. She published articles in Catalyst and Cadence magazine, and even her own publication, the Product Evolution Times. Her 1995 article titled "Make Your Mistakes Quicker" highlighted her unique style of product design. She was the spark that ignited the SOLIDWORKS community and the foundation for most of what it is today. She was the first webmaster of swugin.org. Back then it was known as SNUG. And long before 3D Content Central or Google, she was offering online discussion forums, links to SOLIDWORKS models, and a vast array of engineering resources. Michelle's advice still resonates. Richard likes to tell the story when he was forming the user group in Central Texas. And out of all the advice she gave him, the one that resonates was to feed your guests. You'll always get a nice meal at a SOLIDWORKS user group. There's nothing like the Sunday reception at SOLIDWORKS World. You get to meet up with old friends, meet new friends, and just talk about what you've done and where you're going in the next year. Well, Michelle was one of those people that I saw every year at SOLIDWORKS World. To me, she was a welcome mentor, and she helped me with both my user group in San Diego and my growing business. This, SOLIDWORKS World, is a 3-day, nonstop, drive-it-like-you-stole-it adventure, which comes suddenly to an end on Wednesday afternoon. But for many of you, it continues on with airports and taxis and shuttles. But Michelle told me a secret one year, and now I'm going to share it with all of you. Stick around for Wednesday night. Find some friends, sit down, have some dinner, unwind. The best ribeye steak I ever had was with Michelle in Orlando one year. It was that stop and smell the roses attitude was one of the things that made Michelle so special. Her legacy lives on with the Seattle area SOLIDWORKS Power User Group, the SWGN, and the entire SOLIDWORKS community. Many SOLIDWORKS user groups would never have started without her help. We are forever grateful, far better off for her innovation and inspiration. In honor of Michelle Pillars, SWGN has created the Michelle Pillars SWGN Community Award. This annual award honors SOLIDWORKS community members with the same drive and commitment. For 2010, the award goes to a user group leader, a former SWGN committee member, an annual SOLIDWORKS World presenter, and he also spends a lot of his own time helping SOLIDWORKS users on a daily basis. Please help me congratulate Wayne Tiffany. Wayne, come on up. We'll never forget Michelle and the many contributions she made. Thank you, Michelle.
And thank you, Phil, for that touching reminder of just how important Michelle was to this community. And thank you to all the user group leaders, the user group members, and the sponsors that make the SOLIDWORKS User Group Network the premier organization that it is. I hope to see all of you at a SOLIDWORKS User Group meeting or a SWGN Summit event this year in 2011. Thank you.
Well, I would like to personally take a moment and thank all of the local user group leaders for everything that you do and everything that you've done for us to build those local communities and really, really bring everyone together. It's my great pleasure, once again this year, to introduce someone who founded the company, who created our culture, created our passion for cool designs, customers, and getting it right, and really has been someone who's been with us since day one and still is a real beacon and pulse for us to stay in tune with you. Please join me in welcoming our founder, John Hirschtick. John.
Thank you very much, and let me extend my personal welcome to SolidWorks World. Year after year, I ask you, and you all tell me that one of the things you love most about being here is meeting cool customers and hearing about the great products and cool ways they use SolidWorks. Well, I've tried to pick 3 really cool and amazing customers for us to meet on stage this morning. Our first customer is someone I've known for over 30 years, going back to when we were students together in engineering at MIT. He's not only a brilliant designer of robotic arms and hands, as you're going to see in a few moments, and a great friend of mine, but he's also SolidWorks customer #1, the first order we ever got for SolidWorks. Please join me in welcoming, from Barrett Technology, the founder and CEO, Dr. Bill Townsend.
Hi, John. It's good to see you.
Welcome to SolidWorks World, Bill.
Thank you. Wow. There's more than one user now.
Yeah, there's more than one user, right. I mean, Bill and I, back in the day, we could have had SolidWorks World. I mean, we could have just gone for lunch together.
That's right.
And that would have been the whole thing right there.
And I understand you just hit 1 million users recently.
Oh, yeah. Well, yeah, we have over 1 million SolidWorks users now. And
right.
Yeah, thank you all. I mean, it's you guys that do it, you know.
If the other 900, this is 5,000 seating capacity, right?
Right.
If the other
5,000.
995,000 showed up, it'd double the population of San Antonio, I think.
Yeah, that's true. That's true. We might have more SolidWorks users than would fit in the city. That would be a nice problem. Bill, you know, thanks for being customer #1, but beyond just giving us the order for SolidWorks, Bill gave us a whole lot more. Because when I was originally thinking about the plan for SolidWorks, there's the actual order.
Net 120.
You know, but before we ever took any orders, when I was deciding whether or not to start the company, you know, should I, shouldn't I start it, I went to Bill for advice. He was my friend and advisor, and he gave me encouragement. He said, John, go do this thing. And I got to tell you, without his advice and support and encouragement, we all might not be here today. So thank you, Bill, again. Okay, that was great.
I don't know what you're thanking me for, but I should be thanking you, I think.
Okay.
Yeah.
Well,
anyway.
It's been great. So, Bill, there were lots of robots in the world for many years. Lots of old robots existed before you started Barrett Technology, right?
Yep.
Okay. So why start Barrett? Why build new robots?
Right. Well, we wanted to have robots that worked around people. Before we came along, there was sort of what we call Robotics 1.0, which is robots that go from point A to point B to point A to point B, and do that for 5 years. We wanted to go beyond that. These robots that go from point A to point B were very dangerous around people, and the rule was to segregate the people from the robot. And, you know, it didn't make sense. If you were going to look into the future and there was going to be, like, for example, robotic surgery, how do you separate the robot from the person and do robotic surgery? So we call that Robotics 2.0, and that's, I think, starting to come into its own.
And we actually have video here, like starting with the handshake.
Yes.
These are Bill's robots from Barrett Technology, robotic arms
right,
and
hands.
hands.
So those aren't pre-programmed. The handshake is not pre-programmed. It's just following the forces of the handshake.
Yeah, I think that's iconic of working with humans.
And they're getting force feedback as they do this task. They can feel the very gentle torques as they're grabbing this bag and opening it and manipulating it.
Now, in the real world, they might be looking for something other than a flashlight.
Yes.
Right? Okay. Yeah. And but
you can tell by the military garb.
It's amazing the way you work with soft objects. I've seen Bill's robots unzip a zipper. Right?
Yes.
Look at this.
Yeah, so it's following a path, a trajectory at the end point, and doesn't know that those people are going to show up.
Yeah.
There goes the warranty.
No. Because, yeah, no warranty claims on that one. But again, it's amazing also, having been around Bill's robots a bit, not only are they human-friendly when they touch you, but when you touch the robot, it's just really cool. You grab the robot, it's like grabbing someone's arm.
That's right.
You know? And so what kinds of technology did he have to build in order to get that to happen?
Well, we build gearless drives. So robots today, all robots other than ours, use some form of either gear or harmonic drive, which is a form of a gear. And we don't. We use gearless by using cables, aircraft cables. We get extraordinarily smooth torque, which is something that we need in order to do this force feedback that we have with people.
And no gears.
And
yeah,
no gears.
No gears. And you also have like virtually no backlash. And
that's right. So the backlash
problems, right?
is gone. The friction is very low. Really nice mechanical drives. You know, it's really made our products work well.
And so on the mechanical drives, you pioneered the cable drive system. Now on the electrical side, I know you had some tough wiring problems, right?
We did. Wiring, someone once asked me, this is about 15 years ago, what is the hardest part about designing a robotic arm? And I said, the wiring.
Wiring. And I know a lot of customers tell me the same thing in their own machine designs, their own products, right? The wiring can be a really tough problem.
It can be a tough problem.
Yeah. And so how many wires did you have running into the robot?
We had roughly 100 wires going into the base of the robot to service 7 motors.
And those wires come from the big controller cabinet,
That's right. It comes from the big controller cabinet and things about the size of a refrigerator. And, you know, it's just massive.
Yeah, something most of you would be familiar with, a big cabinet of motor control electronics. And how did you solve this problem with the wires?
Well, it was sort of by mistake. You know, it's like a lot of inventions. It started out with, we were trying to get smoother torque, and these motor controllers did not give us the smoothness that we needed. And it turns out, and we just got a patent on this 2 weeks ago, it turns out that if you make the controller really small, keep the distances very short between components, that the torque becomes very, very smooth and very important to us. So by making it small, all the components that normally are there, our invention gets rid of a lot of components. So we're able to make it small, but we needed to use SolidWorks in order to nest the components together.
Now wait, when you say small, you took the refrigerator-sized box of motor electronics. How small did you make it?
Well, I brought one with me. I by mistake, carried this through airport security.
Oh, that must have been interesting.
Yeah. And they never stopped me. It looks like a coin.
So this is what you call the puck, right?
This is what we call the puck.
And what's in there, Bill?
An entire motor amplifier is in here, and also the encoder function is in here. And there's a 32-bit DSP, so it acts like a PC basically. So
you took you took all that controller electronics and power electronics and put it right at the point of the motor in that little puck.
Exactly.
It's about the size of what used to just be the shaft encoder.
Yeah.
Right.
And
Pretty cool, really.
Yeah. It's a nice
I think
trick.
that's really cool. And so, Bill, and how did you mentioned you used SolidWorks to fit everything together to fit those boards?
That's right. We needed to dovetail the electronics. We have a pair of 10-layer boards that come really close together, and the components on those boards had to be nested. So it was a very complex design problem because electrically it has to be right and mechanically it has to be right.
This is really amazing. So, and what happened to the count of the wires by doing this?
We got to a count of 4.
4 wires.
Four wires.
He went from 100 wires to 4.
Yeah.
Yeah, just 4 wires. Yeah, it is. I'm going to give you applause too, because it's just awesome. I mean, you see the robot doing these amazing motions, and then where's all the wires? And there's no more cabinet, right?
Right. Yeah.
I mean, there's no motor cabinet. Guys.
We used to have 3-phase power, 20-amp line. So this is a controller.
Oh,
cabinet.
right, the power too. This blew me away when Bill told me about the power. You got it. Yeah. So you had, of course, you'd expect 3-phase, 220 3-phase coming in that box,
That's
right? That was the old way, right?
Yeah.
With the puck, what happened?
Well, with the puck, it also was serendipitous that the invention calls for this to be very simple, and it's got not the amount of electronics that those controllers have. The amount of power that it takes to run a WAM today, which is WAM is the name of our robotic arm, takes 5 9-volt batteries, and that'll run it for 20 minutes.
Yeah. You got that, guys? He can run the robot you saw doing the human-like motions. I've seen it. I've seen it with my own eyes on 5 9-volt batteries. It's unbelievable, and it is. It's really unbelievable.
Thank you very much.
And I'm really hoping that you can not only hear Bill's story and say that's cool, but many of you go back. For those of you who are doing machine design, maybe you can use some of these lessons, right? Push the electronics out to the motor. And not only do you reduce the wiring and get better results, but you reduce that power consumption, because so much, what I learned from Bill is so much power is wasted in these electronics with no value add. So amazing, really amazing story. Bill, you have to feel great. You've come so long in your life dedicated to making these human-like robots, and now you're seeing them used in all kinds of cool applications. Thanks for being customer number 1. Thanks for sharing your story with us.
Thank you.
Really appreciate it. Now, our next customer builds on Bill's technology. It's a friend of Bill's who looked at Bill's technology and applied it to the problem of robotic-assisted surgery. Very, very cool. Please join me in welcoming the founder and chief visionary officer of Mako Surgical Corporation, Roni Abovitz. So thanks for coming. Roni, what does Mako Surgical do?
Mako Surgical makes human interactive surgical robotics that assist people to get back on their feet very quickly, and we do knee and hip surgery with it.
And so what happened that inspired you? How did you get inspired to try and change the way the world does surgery?
Well, really early on, this is a true story. It's just probably like most of the audience, growing up watching Star Wars, playing Atari, and breaking all my bones playing baseball and football, and that all got mashed up in my head and sort of came out as surgical robotics. That's like the meta theme of what happened here.
It's a lot of fun hanging around with Roni here, as you're going to see. So, but seriously, so you grew up. That's important as a child, like a lot of us, into technology and breaking some bones. And you went to school. What did you study in college?
I studied mechanical engineering and biomedical engineering. I also was a cartoonist, so all that together mattered.
Oh, really? And you're an engineer. You're not a doctor.
Engineer, not a doctor.
Establish that right now. You'll see how.
Although I play one on SolidWorks World.
You play one in SolidWorks World, yeah. And so, tell us about what was your first job after biomedical engineering school?
My first job as an eager beaver engineer coming out of school was working for an Italian orthopedic implant company. They design hips and knees. And they sent me to go learn about hip surgery from a surgeon. So I go into the operating room, and I'm real excited, and the surgeon brings me right up to the patient. I'm like, this is so cool. He opens up the patient, and I'm like, wow, and he's got the incision, and he turns around and looks at me and goes, what do I do next? And I'm like, who are you talking to? And he says, you're from the company. What do I do now? I'm like, you must be. I'm not going to say that word. And he's like, no, seriously, what do we do now? So I run down to my car, I grab the instructions for use, they were in Italian, and I'm like freaking out. And I also had bought a textbook on orthopedic surgery from the local med school, and I run back to the room and I got these things open, and I'm like, you're really serious? He's like, yeah, what do we do now? I said, pick this up, pick that up, and we actually, you know, we got our way through the surgery. I think this is going to be okay. I'm improvising. Not quite like yesterday's Apollo 13, but, you know, at a very small scale.
Yeah, it's a pretty serious issue, though. And so, and you also told me about that the process was way more primitive than you thought.
It was
right?
very primitive, and I think like the inspirational moment for me to do what became Mako was he's sawing off the femoral head, which is sort of like the ball and socket of your hip. And I'm in there looking, and the femoral head literally just pops out, bounces off my forehead, and I'm covered with blood and sprayed. And I'm going, there's got to be a better way to do this.
Yeah, you know, it's like, you know, we all know that when the apple fell on Newton's head, you know, he started thinking about gravity, and the bone hits Roney in the head, and he's a young engineering student, and he says there's got to be a better way.
There's got to be a better way.
So tell us about, so you had a vision, an inspiration. Tell us about your vision. What was it?
So the vision was like initially like this cloudy thought about robotics and software as sort of a process to make things better in surgery. And then a professor friend of mine, a guy named Mike Peshkin from Northwestern, said, you got to go meet this guy named Bill Townsend. He's doing this really far out stuff with robots that work with people. Go see if this makes any sense. I go up and meet Bill, and he's got this robot that's like throwing baseball pitches. And I'm like, I love baseball. This is great. And we're talking about stuff, and he's talking about this whole future of people and robots, and I'm talking about robots doing medicine. I said, Bill, I want to take your robot to med school. He thought that was totally cool, and it was like a totally serious conversation. And he took me seriously, and I was like, this is awesome. And I was so excited that we were going to go change the world.
But other people didn't, not everyone got it the way Bill did, right?
Oh, absolutely not. Bill was like maybe several decades ahead in time. And, you know, I'd go to a surgeon, I'd say, you know, do you want to help invest in this company, be part of it? And it's like, what are you talking about? It's like robots and haptics. And he's like, get out of my office. And then I'd go to the next surgeon and I'd say, robot, get out of my office. Who are you, a kid? Get out of my office. You know, it was just all that kind of get out of my office till it was like a bad sitcom for a while.
And you spent like 10 years, and you finally raised money. You know, it's real persistence of vision for Roney. And you raised money and got the company started, right?
It was 10 years like wandering in the desert, eating rattlesnakes, like sipping water out of cactuses. But finally, we actually raised a couple $100 million and went public in 2008. So it did have a small, it finally came together.
And what's the product system today that you offer from Mako?
So Mako's product today, it really builds around the process in surgery we call Makoplasty, which is the whole thing that we do for the patient. But it's built around a Rio robotic platform, which is the only human interactive robotic device built for orthopedic surgery. We also build application software, the instrumentation, I think most importantly, the first set of implants designed to be put in people with robotics.
And you start by scanning the patient's knee, right?
Yeah, there's a, here we go. So we start by getting a scan of the patient's knee, and that magically becomes a 3D model of the knee, which actually works, and we do the biomechanics of what that patient's knee is like, and we actually figure out exactly where their implants need to go. It's a bit like a flight plan for the surgeon.
So you take the knee scan into your software, right, which is up there?
We take the knee scan into our software, which is a bit like a CAM system.
Yeah, a CAM system for bones, kind of, right?
And a little quick geek out for the SolidWorks group. All the implants are designed in SolidWorks, but the implant models get loaded into our software, and we make haptic models of those implants in SolidWorks too. I think we're the only company making haptic structures in SolidWorks to be used with robotics.
Yeah, he designs things in SolidWorks that don't exist, but give you haptic feedback. And you know what was super cool? I went to visit Roney, and he actually let me do a knee surgery on a plastic skeleton.
Yes,
okay,
not on a real person.
It wasn't real, but I felt like I could do it on one. You know, if any of you want to let me do it, I mean, I guess you could try. But it was
I'm not commenting on that part.
It was just so cool. I mean, you go in and you bring the cutting tool to the skeleton, and his CAM program guides you. It only lets you cut where you should be. It's impossible to cut any of the surrounding tissue, which would be a little bit of a problem.
And I think the key there is this idea of the robot and the person working together. The robot does not do it by its own. It's the human and the machine interface, which I think is a really important design principle for the next, 30, 40 years before robots take over. And then SolidWorks 2050 will be robots laughing at this conference, and there are people here.
Yeah, that would be very interesting. We could ask James Cameron about that from last year, right? But now, I got to see everything you were doing with SolidWorks, and it's super cool, but one piece we want to talk about in particular is how you use SolidWorks surfacing to get these implants right.
Yeah,
really cool story here.
This was a real challenge because we brought in some real ace designers who had designed a variety of knee and hip implants, and they see that we're using SolidWorks, and they're like, you know, I need to get a Unigraphic system or Pro E because we can't do these fancy surfaces. And we wanted to really push the envelope because Mako was doing super anatomic, very organic shapes that were even pushing what anyone was in orthopedics. So I call up John. I'm like, John, you got to help me out. We've been on SolidWorks so long, we can't like bail out now.
Yeah.
So they connect me with some great folks, and the surfacing problem was really resolved in a matter of weeks. It was amazing. Our team did a wonderful job. But the process was we take clouds of data from the knees themselves. That data cloud actually drives a parametric model in SolidWorks of all of our knee shapes for all the different sizes, and we have all these interesting ratios to get a perfect fit on your knee based on this whole family of hundreds of knees that we gathered, and it all happened in SolidWorks and it was great.
Yeah, great use of surfacing. Now, how many surgeries have you actually done?
We're almost at 6,000 procedures today.
Almost 6,000 people have had it. And we actually have a patient, yeah, it's amazing, yeah. But, you know, sometimes it's one thing to say 6,000 people, but it's a whole lot better to meet someone live in person. Please join me in welcoming an actual Mako knee surgery patient, Mr. Samuel Brooks.
Hey, John.
Hey, Samuel, welcome.
Hey, Ronnie.
So glad you could. I watched you hop right up those stairs, and, you know, you wouldn't know. Look at this. You know, we couldn't even tell which knee was the Mako knee and which one.
Which one? If I do
Can
a couple
anyone
of
tell?
bends?
I mean, I mean, you know, this is what it's all about, guys. I mean, we build the software, you design products, you know, but all of it's for nothing if it doesn't get to a customer and get to people of the world and do some good. And that's what's so great about having you here. You know, tell us how long was the surgery?
Of course, I was asleep during the surgery. I don't know how long that took.
Yeah.
But I do remember waking up in the recovery room and knowing that rehab was going to be the hardest part of, at least what friends have told me.
Yeah.
I went ahead and started flexing while I was laying on the bed in the recovery room. And I was told that was not something that normally happens, you know. But anyway, 2 hours later, I'm in the room, and the urge hits. Well, I'm telling the nurse, I got to go, so let's walk over there. And I walked, actually, 2 hours after surgery, I was walking from the hospital bed to the restroom and back again.
2 hours after knee surgery, he's walking to the men's room. Ronnie, you gotta feel awesome. Yeah, look at that. That's it. You know, we talk about emotional paycheck. You know, it's really 2 hours. Now, with traditional knee surgery, Ronnie, you explain to me, does anyone, if someone, you know anyone who has knee replacement surgery? Are they walking 2 hours later? I mean,
no.
You know, it's just crazy.
It's weeks of rehab and recovery and months of really trying to get yourself back together. It's a totally different thing. It's a major, major surgery. It's very invasive.
Guys, I was playing golf 3 days after surgery.
Playing golf 3 days later.
I was actually on the course.
You know, and that's a surgery that in the past would have been total knee replacement. And how about the result? How does the knee work for you now?
It's been a year and a half, and actually this one kind of pains me more because there's arthritis in that one. In fact, maybe Ronnie will let you do mine. You know, a couple
of
yeah,
there you go. I got a new job. I'm gonna
have John do that.
Yeah, I'll go to Mako World and show him how to do the surgery. Samuel. Samuel, your results. So you're saying the knee works? Does it work as well as it did when the knee was healthy years ago?
When I was having, of course, I was bone-on-bone arthritis, and it hurt so much I would not want to walk. I was a literal couch potato, ballooned up 300 pounds, something like that, you know. And hey, after this thing, being able to walk again, being able to bicycle, you know, do things with my family, it's just amazing. I can't thank these guys enough.
Well, it's the ultimate reward, and Ronnie. Yes. You have to feel great. You stuck with your vision for a decade, and now there's thousands of people who have benefited. And
hearing this is the payoff.
You know, someday I have a feeling there's going to be millions. And so, anyway, thank you both so much, Ronnie, for sharing your story. Samuel, for showing us what it really looks like in the end. Thank you guys both. We will. You know, it's just, you know, we always say that the most exciting thing for us is seeing customers do great things with SolidWorks, and here's the proof, you know. And it's so great to see building robotic technology, Ronnie taking that technology and building into a system, a wonder of systems engineering that gives people benefit. Now let's move on to our third customer. And first, I'm just going to tell you that I'm seeing in you, in our customer base, over the last couple of years, an emerging trend of using open source design processes to build your products. I've seen open source type processes applied to consumer products. And believe it or not, we're going to share with you this morning the story of the first open source designed car. There's actually a car that's been built using open source design techniques. Let's take a look at Local Motors Corporation.
Even if you were the richest, smartest, most talented person in the world, it would still be really hard for you to make a new original car. Now you can. Join the Local Motors co-creative team to help create, develop, build, and mod brand new cars. Here's how it works. First, join the community. Everyone is invited. Next, create new cars or help develop ongoing concepts. If you're a hot designer, create new cars by participating in a competition or submit a design to Checkup for review. If you love cars, vote to decide what will be developed. All designs are protected with a Creative Commons license to promote collaboration, but protect your design ownership. The concepts with the most votes are developed in co-creation. Co-creation is working with your peers and the Local Motors team to help choose things like the body and interior details, and components like engines and shocks. You help develop the car and ensure it turns out the way you want. Once a car is fully developed, you can buy it and build it. Local Motors opens a microfactory in your region to build the cars you want to build. For example, Local Motors opened a microfactory in Phoenix to build the Rally Fighter. There are many more microfactories to come and more cars to build. So far, the LM Extreme is the most popular in the Carolinas, the Green Apple is favored in Manhattan, and the Boston Bullet in Boston. Microfactories mean local jobs and the most convenient service. The microfactory model is also sustainable. Since cars are built one at a time, there is less waste. Plus, Local Motors businesses allow the use of locally available fuel sources and more rapid adjustment to changing technology. Not only can you be proud of building your own car, you can be proud of buying local. Your car is special because you make it. You can even design or choose a custom car skin for the body. Every car is numbered. Only 2,000 of each design will ever be made. It only takes 2 3-day weekends to build your car in a Local Motors microfactory. Local Motors provides you all the help you need, but you are the lead builder. You can even bring someone to enjoy the experience with you. At the end of the second weekend, you drive your car home. With new understanding of how your car works, you are a better, safer driver. So when you complete the build of your own car, you join the ranks of the most responsible car owners in America. Once the car is home, you can mod it. All chassis and body data is available. Modders, fabbers, and manufacturers, click the download button to retrieve all the data you need to build anything for the Rally Fighter. You can even sell what you build through the Local Motors website. Local Motors is not only co-creative, it's open source. It's that easy. You can make a new original car. Just join the Local Motors community to help create, develop, build, and mod your car the way you want.
Pretty cool, huh? So now let's give a big SolidWorks welcome to the Local Motors head builder, trainer, and vehicle R&D engineer, Mike Pisani.
Hey, John.
Hey, Mike.
Thanks.
Well, thanks so much for making the trip to join us. I
Sure.
love the Local Motors uniform there that you're
Thanks.
You've been in the car business a long time personally, right? Even before Local Motors.
Right, yeah, I've always been interested in cars ever since I was a little kid, like a lot of people on the audience there, I'm sure, and all my other fellow teammates at Local Motors. But with some hard work and a little bit of luck, I was able to turn my passion into my profession, and able to do that. Actually, it's kind of a random story that we just put together this morning. I started with SolidWorks, I believe it was a seat of 98, while on co-op at ZCAT, which was, again, Roni's company, and we just put it together this morning. I didn't know he was going to be here.
Yeah, a funny thing, Roni, the previous speaker, Roni and Mike met this morning on stage here, and it turns out Mike used to work for Roni when he was a college student. Total coincidence, and it shows you we're a million people, but it's not as big a community sometimes as you think.
Right, and it was
feel
great
like
to see
family. Yeah.
And then from there on to working with Factory 5 Racing after graduation, and then now on to Local Motors at its inception to help develop the Rally Fighter.
So how long did it take Local Motors to build the Rally Fighter, the first car?
It was about a 15-month period to go from literally a 2D sketch on a piece of paper to the first working prototype, and then a few months beyond that to develop tooling and things. So about 18 months overall. We feel like we can hone it down to 12 to 18 months, once we get things rolling.
So they designed this car, the Rally Fighter, built from scratch in less than 2 years.
Less than 2 years,
amazing.
yeah.
This is an amazing car, as you can see. It's a beautiful car.
Right, which is typically a process of 5 to 7 years.
5 to 7 years, yeah. And everything was open every step of the way, right?
Right.
And how many community members do you have in the online Local Motors?
Right now, to date, we're at about 9,500 registered and active users on the site, and that's comprised mostly of transportation designers, engineers, and the most important person in the equation, the enthusiast, the customer.
And we promised Local Motors that we would make it really clear that we'd invite every one of you to join the online community at localmotors.com. And I have a feeling there's going to be a lot of people in the audience that are going to go back and join the community.
Right, and it's very easy to do. You just log on to the website. You can upload your own designs that you've worked on in the past. Maybe even if it's a sketch you've done on a napkin, load it on there. Get it critiqued if it's an idea maybe you've been wanting to work on, you just haven't had the chance to get it critiqued. Load that design on there, and then of course contribute to the rest of the designs and add your CAD and engineering expertise to existing designs on the site.
And so now tell us about the overall process of how you design the car.
Okay, so what we do is our core competency is not in developing braking systems, engines, transmissions, so on and so forth. What we do is, what we're good at is taking all of those best of the best components and putting them in a package that we feel people will want to buy. And again, when I say we, that's not just us at Local Motors, that's the whole community. So we take things from the SEMA tech transfer, and that's mostly models from GM, Ford, Chrysler. You can put in a request for an engine or a transmission, which you can see in the model we have. You can also get components from some other of the automotive manufacturers, but mostly the big three. We also design our own components like the chassis, some of the suspension components, some of the other smaller components. The body and the body tooling is developed in CATIA and then brought into SolidWorks as an IGES file. And the wheel, instead of designing my own wheel when I first started the process, because I knew we would eventually purchase a wheel, instead of dedicating the time to start from scratch, what I did was I went to the 3D Content Central site, found a wheel that met our specs, and used that in the model to run my suspension simulations and make sure that the wheels would fit in the wheel well, so on and so forth. And then another method that we use, which I think is pretty cool, is in the event where we can't get the data from a SEMA tech transfer or one of our suppliers, is we'll purchase the part, scan it, and then use that in the model. And if we need to make some modifications to it, we can do that. It just kind of increases the speed to reverse engineer a component.
And Mike, you brought an example of a part that you scanned and re-engineered, right? Can we take a look?
So what we have here is, this is an actual component that you can purchase. This is a yoke for a drive shaft, and then what we have here is the part that we ended up with. And what we do is we purchase the part again, we will scan it, and then make our changes, which you can see it's a little bit shorter. We've increased some of the bosses on the side. This actually also has splines in it, so we can actually take this part and put that on the other end of the drive shaft to make sure that the components fit properly. And what this is the scan data that came from RapidForm, then sent to our Z Corp 3D printer.
And so this comes right out of the 3D printer, just like this, with all the splines and everything in it.
Right. There is some infiltration to be done with either a cyanacrylate or an epoxy just to hold it all together. Because again, if you are going to join the parts, but that came from a powder printer.
Cool. And it's, Mike, like a lot of customers, we're seeing more and more customers using scanning routinely. It used to be a big deal to think about scanning a part, but you use it, handheld scanner, right?
Right, handheld scanner with the IR targets right on it. You just set it up, and in a matter of an hour or two, you can have a pretty large assembly like the fuel tank, like you see in the model. The forward rear end, we also scanned that and put that into the model so that we could package around it.
Oh. So which parts of the car have had the most involvement from the community?
Well, I'd say the body components are certainly those that have the most involvement because it's the most defining feature of the car, and there's a lot of opinion on how it should look and how it should be manufactured. So again, we have the transportation designers, the engineers, and the enthusiasts all collaborating live on the site to decide which direction the car should head. And in the case of the Rally Fighter, that was a student-submitted design from Sang-Ho Kim, a student at Art Center College of Design in Pasadena.
So Mike, I just want to really emphasize this point because I was blown away when you told me this. That, sure, I could imagine open source helping in the design of the car, and maybe doing some of the components you're going to talk about. But the actual overall design concept for the Rally Fighter, the sketches like the ones you see here, I don't know if that's actually by him, but these kind of sketches came from an open source contribution from a student. As Mike said, a student penned the car concept, and now 2 years later gets to see that car driving down the road. I just think that's really, really cool.
Yeah.
And I think the world has changed in some fundamental way when a student can draw a shape of a car and 2 years later see it on the road. I just think that's profound and interesting, and we've got to think about what that means for our own processes.
Right, and anyone can upload a design of any level of finish, and again, you have 9,500 to date users on the site, so you've got all of these people that are professionally trained in, again, design, engineering, so on and so forth, to be able to critique your design. And of course, the customer can say, I'd buy it or I wouldn't. So for a young guy like Sang-Ho Kim to be at school and to post a design that was on his profile and get all this critique and then eventually have Local Motors build it because the community has said, hey, Local Motors, you guys need to build this car. It's pretty cool.
And you had some competitions, right? We're also part of the...
Right. We also have involvement with components for the vehicle, such as the side vent, and the interior also came from a competition. We've actually even given away seats of SOLIDWORKS as prizes for the competitions, again, to build that engineering base. So we get feedback and input from all aspects of the car.
And how do you take the car design and from a concept design to reality, to manufacturing?
Well, the Class A body surfaces, again, are developed in Alias and CATIA. The chassis and suspension components are in SOLIDWORKS. And again, as I mentioned, we try to use existing components wherever possible, wherever they fit on the design, and we can get them in the right numbers at the right cost. A couple of examples of that would be headlights and taillights. Rather than developing our own, which could be several $1 million to do to develop all the molds and everything, we actually use kind of a neat process of combining the surface data and our printer. So what you can see here is that the image on your left is a mold that I printed on our 3D printer in a number of different sections, and then we taped over it so that the fiberglass that we laid on top of it, which is the middle image, could be released from the mold. And then once we released that from the mold and trimmed it down along the edges, we actually took that piece to a mall parking lot and went and kind of set it over a number of different cars to see how our shape worked with existing designs out there. So you can imagine at Christmas time in the mall, going out and holding a piece of fiberglass up to someone's car. Some people were kind of like, "Why? What are you doing?" But we weren't touching it actually to the car. But it turned out that the Honda Accord Coupe actually fit the design really, really closely. So then we went back and made a couple of changes to the surfaces. We ended up not using it because we wanted to maintain the P51 Warbird inspiration of the car. So we actually went a different direction. But it's kind of a neat process that we used to get to that point.
Yeah, and I think I've met a lot of customers, but that's the first time I've heard of matching up cars in the mall parking lot as a design technique.
No car is safe.
Yeah, no, you know, that's pretty interesting. But it shows you seriously that Local Motors is a collection of an amazing variety of tactics and processes to get the parts made, all with the goal of making a cool product really fast. And it sounds like you'll just use whatever technique works best.
Right.
And that's a really, you know, really powerful story there. And, how much of the CAD data is really available for download on your website?
It's all available on the website, all of the components that we design. So again, the body, the chassis, suspension, some of the other components are all available on the website, as well as some of the OEM and aftermarket components, again, that we've either received from the manufacturer direct or through SEMA Tech Transfer.
So anyone can go to the site and download real original CAD files. So those aren't dumbed down or defeatured files,
it's
right?
the SolidWorks file, and we also have IGES format as well for someone, those kind of other guys that maybe are using a different package.
Few other people in the world, maybe. That's, you know, again, just really cool. And it's really easy to do. You can go try it. But wouldn't you be worried about competition? You know, when I saw this, I thought, are they worried that their competitors are going to take those CAD files and do something with them?
Well, we don't really have a concern with that, because the speed to innovation and the speed to market is one of the safeguards that we have, because to replicate what we've done is a major undertaking, so we'll always be a few steps ahead. But we fully expect that the data will be downloaded. We want it to be downloaded. We want our customers to take the data, download it, and modify things for a light rack, for bumpers, things like that, so that their car is more usable for their application. Then upload their story and what they've done. Maybe they've done it themselves. Maybe it was a fabrication shop that did the work for them. Load that onto the website so that the other people that are like you out there can take that data and make it usable. And then from there, what we could do is we could offer that either as optional equipment or maybe standard equipment from there on if we see that a lot of people are using it.
And so I have to ask, are you personally going to buy a Rally Fighter?
Definitely, but you know, I'm sure like a lot of people in the audience today, I have a long list of projects that I'm working on in various different stages, so it's next on the list. As soon as I get those done, I definitely will.
But anyone in the audience who wants to get their name on the list, reserve a spot on the build list, how much is that deposit?
Right. The list, as you saw on the presentation, the video that we had, will only build 2,000. Currently, we have about 135 deposits down. It's just under $1,000 to reserve your spot.
There you go. Maybe you've sold a few right here in the audience.
Maybe.
It's possible. Mike, you know, what should the audience take away? We got an audience of product designers. Should everyone run back and say, let's convert our design process to open source, or what would be the right lesson to take away?
Well, I can't say that it's for everybody, and I can't say that there aren't any growing pains associated with going from being kind of an engineer locked in a room with no windows and keypad entries, only releasing your designs once you feel that they're perfect, to being fully open source with everything that you do. But once you do that, you'll notice that, like we have, you smash that wall down in between design and engineering that we feel typically exists in a lot of places, not just in automotive manufacturing today. And when you do that, you'll realize that community development means better designs faster. You've got all this input from, again, the three key players in the game, the transportation designers, the engineers, and the enthusiasts, so that you make sure that you're moving down that path every step of the way, making something that people want to buy, and it's something that's manufacturable.
So the message sounds like, think about open source. Think if there's even small steps you can take to open up some of your product development process and maybe have a better process and a better product.
Yep,
and that sounds
for sure.
like great advice to take away. Thanks for that, Mike.
No problem.
And well, I can't thank you enough for taking the time and out of your busy schedule building cars to get over here and share the story with us. Yeah, thanks so much.
Thank you very much.
And,
yeah, just a reminder to everybody again, go on to local-motors.com, upload your portfolio of work that you've maybe been kind of tucking away, saving for a while, and also critique some of the other designs that are out there.
Thanks, Mike.
John.
I'm sure some of these people will. Some of the users will do that. Thank you. You know, yeah, I know some of our users will go onto that site, and maybe the next time we see a Local Motors car on the road, one of you will have designed it. That would be cool. I want you to know, when we tell you that Local Motors says you should consider open source design, it's not just for you. We're thinking about it too at SolidWorks and Dassault System. With the Dassault System Swim platform, which many of you may have used already, we have a tool for enabling much greater collaboration between our development teams and our users and among our users in planning new products. And we've put that to work with our new Draft Site product. If any of you have joined the Draft Site community, you can see that we're starting to open up our product development processes more to you. And maybe, do you think it would be a good idea if we opened up more of the SolidWorks development process? Would that be a good idea to make more of that visible to you? Yeah, you know. I hope I'm not getting in trouble with management here, but I think it would be a good idea. I also wanted to thank the resellers. Behind each of these great customers, there's a SolidWorks reseller. Tim Preston at CAD Edge, Mike Pomper at the Solid Experts, and Pat Lindsay and his team at DDI. Those are the resellers are really the key to making our customers this successful. I hope you found these stories cool and amazing. I really love these customers. I love all our customers. It's still exciting to me to see what you do with our software. It's exciting, it's fun, and most of all, I learn something every time I see a customer and hear their story. In closing, I just want to remind you that as a founder of SolidWorks, I get asked really often, John, what was it like in the old days? What was it like at the beginning? What was it like when you were just getting started? And I have one message for you today. Today, now, this is still the beginning. Today, now, we are just getting started. Have a great SolidWorks world, and let's go design.
I'll point out one other thing about these guys. You know, they're not only speakers at the event. As soon as we talked about the event, they immediately got registered. They've been attending sessions. You may see them in some of your breakouts today. And you may see them at the special event we have tonight. I'm supposed to remind you of it. It's at the Cowboy Dance Hall. It's going to be some cowboy dancing. Are you guys cowboys ready to dance? We have buses. They depart at 6:30. And I've also been told you're going to get a map provided at lunch that will help you get there if you miss a bus or need to navigate your way home. So I hope the event continues to be a great success to you as it is to me. I appreciate the time to talk to you. This ends General Session Day 2. Look to see you tomorrow, General Session Day 3, where we look at the innovations that will be coming out this year. Thank you.